Okay, we are going to talk about inverse trigonometric functions. We are probably going to talk the entire period about them. You'll have homework tonight, and then tomorrow will be a day where we'll just reinforce what we learned, okay? So let's first think about inverse functions, okay? We had something called the horizontal line test. Does anybody remember the horizontal line test? What did it test for? Nope. A vertical line tests to see if it is a function. A horizontal line tests to see if what is a function. The inverse is a function. Okay, so you were on the right track. Okay. Now, next week we are going to graph sine, cosine, and tangent functions. We haven't done it yet, and you don't need to write this down. Okay, I'll tell you when you need to write something down. We're going to write down the inverse sine function. Just let me get you there. Okay, this is what the sine function looks like. It goes like this in both directions. Does this pass the horizontal line test? No, it does not pass the horizontal line test, but I'm telling you that there's an inverse sine function. That's weird. Okay, so let's go ahead. I'm going to show you what happens when we reflect about the line y equals x. That's how we get okay, so this is what it would look like if we reflected it. Okay, it's not passing the vertical line test. So what mathematicians did, they said, you know what, let's just take a part that would pass the vertical line test. I'm going to highlight this portion right here. If I cut out the rest of the graph, would this highlighted portion be a function? It would be. Okay, so this is what mathematicians have defined to be the inverse sine function. Okay, and this is what I want you to write down about the inverse sine function. The inverse sine function has a domain of -1 to 1, a range of -pi/2 to pi/2. And notice we have two different notations, arc sine of x and sine inverse. Those mean the same thing. I don't really care about the graph. I care about the domain and range. So arc sine and sine inverse mean the same thing. Okay, our domain -1 to 1. Notice how that's the different numbers that stretch on our unit circle. Our unit circle has values between -1 and 1. Okay, our range -pi/2 to pi/2. If we think about the unit circle, what quadrants will those outputs come from? -pi/2 to pi/2. What quadrants would those be? Yeah. Okay. Here's -pi/2. Here's +pi/2. So in the first and fourth quadrant, we are going to be able to pick angles in those two quadrants to be the output or to be the answers of an inverse sine function. Okay, what does that mean? Okay, when I'm asking you for when we're talking about an inverse sine function, since we're switched, our angles are now the outputs and the ratios are now the inputs, okay? So instead of saying the sine of pi over 4 is radical 2 over 2, now we're going backwards. When I ask you for the inverse sine, we're going to put a ratio inside and our answer is going to be an angle. So this is asking us where, okay, so inverse sine of radical 2 over 2. Where between negative pi over 2 and positive pi over 2 is the sine radical 2 over 2? What's our answer? Pi over 4. Okay. Similar to what we did Thursday, I gave you a ratio, we're finding an angle, but our inverse trig functions are very, very, very picky about what kind of answers they push out, okay? So let's talk about if we had the arc sine or inverse sine of negative radical 2 over 2. Our answer has to come from the range negative pi over 2 to positive pi over 2. So we're either going to rotate to the first quadrant or down to the fourth quadrant. So if we're talking about a negative ratio, which quadrant are we talking about? Quadrant 4, okay. But instead of 7 pi over 4, that does not fit in this range right here. It's actually kind of nice. We're just going to rotate in the negative direction to negative pi over 4. Okay. Your answer for an inverse sine function is always going to be an acute angle, either a positive acute angle in the first quadrant or a negative acute angle in the second. And by second, I mean fourth. A negative acute angle in the fourth. Okay. All right. Let's talk about inverse cosine. Okay, this is something don't write down right now. Next week, I'm going to teach you how to graph a cosine curve. And when I teach you how to graph a cosine curve, it'll look like this. Pretty similar to our sine function. It just starts at a different place. But notice how we have like these waves. Okay. Does this pass the horizontal line test? No, which means its inverse is not going to be a function. Okay, so let's talk about making that an inverse. Okay. Okay, there we go. This does not pass the vertical line test. Not even a little bit. If I highlight the same part I did last time, does this pass the vertical line test? No, we got to pick a different part. This part right here is the graph for inverse cosine. Okay, so here's what you need to know. Arc cosine or inverse cosine, one or the other. This is what you're going to write down. Our domain is -1 to 1. Our range is 0 to pi. I don't know where that negative came from. Just to confuse Claire, that's why. Okay, so now our domain's the same, you notice that? But our range is now 0 to pi. Now, which quadrants would our outputs come from for inverse cosine? 1 and 2, okay, that's different. Okay, when we're talking about our outputs for inverse cosine, 0 to pi come from quadrants 1 and 2. Okay, if we kept the same range as inverse sine, notice how cosine is positive in the first and the fourth quadrant. So if we were first and fourth quadrant, we wouldn't have any negative ratios, and that's not okay. So that's one of the reasons why we're sticking with 1 and 2. We need some negative ratios, we need some positive ratios. Okay. So this is a little bit more straightforward. Okay, we just got to keep in mind only first or second quadrant. So if I ask you for the inverse cosine of radical 2 over 2, since it's a positive ratio, our only option is quadrant 1. That answer would be pi over 4. But what if I ask you for the inverse cosine of negative radical 2 over 2? That output isn't going to come in the first quadrant. It has to come from the second quadrant. What's that angle? What does it hang? 3 pi over 4. All right, and then last but not least, don't write these graphs down for right now. Let's talk about the inverse tangent function, okay? So next week, I will teach you how to graph the tangent function. And the tangent function, it's pretty cool because it has asymptotes. Did you have a question or just a comment? Okay. Does this pass the horizontal line test? No, just say no, it doesn't. Okay. We have multiple swishes here. And if we turn this sideways, we're going to have swishes that are all stacked on top of each other, but we could just choose one of the swishes. Okay. And the one swish that our mathematicians came up with is this swish right here. Okay. Our inverse tangent. Oh, this is so nice. Our domain is all real numbers, but our range, notice how this is a non-inclusive interval, negative pi over 2 to positive pi over 2. You know what? I kind of like this. We once again have a range that consists of negative pi over 2 to pi over 2. Now I know this has parentheses and inverse sine has brackets, but our outputs are going to come from the same quadrants. Since our range is negative pi over 2 to pi over 2, the outputs for an inverse tangent function are going to come from the first and fourth quadrant, just like inverse sine. Okay, so inverse sine and inverse tangent are calculated similarly. Acute positive angles in the first quadrant, acute negative angles in the fourth quadrant. Inverse cosine is just our oddball. So if I were to ask you to evaluate the inverse tangent of 1, we're going to find an angle in the first quadrant whose tangent ratio is 1. Which angle is that? But if I change this to the inverse tangent of -1, I have to find an angle now rotated down negatively in the fourth quadrant. Okay, you're not going to tell me 7 pi over 4. I know that's in the fourth quadrant, but we have to stick from negative pi over 2 to pi over 2. So instead of rotating all the way around to the fourth quadrant, we're just going to rotate in the negative direction, negative pi over 4. All right, so we'll do some practice. Ready? Do some examples. First one, the arc sine of -1/2. Just write it down. It's not 12. You stand up, buddy. You need to stand up.
No, I actually close my eyes to sleep.
Okay. Not to sit. Okay, so we know that arc sine comes from the first or the fourth quadrant. Which quadrant are we going to focus on? 1 or 4? 4, because we're talking about a negative ratio. Now, in general, which angles have a sine ratio of 1/2? Which angles have a y coordinate of 1/2? Our 30-degree angles. So in the fourth quadrant, if we rotate negatively, we're talking about negative pi over 6. I do want these answers to be in radians, please. Okay. Technically, we've already talked about this problem. The notation is different. I want you to understand that cosine inverse and arc cosine mean the same thing. So when I say arc cosine of radical 2 over 2, which angle am I trying to get you to say? Pi over 4. I bet you are pretty good with your calculators now, and I want you to use. I will let you use your calculator on some things. So I'll let you reach for it right here in a moment. All right, inverse cosine of negative radical 3 over 2. Tell your neighbor which quadrant this needs to come from. I'm hearing 2. Okay, I'm hearing quadrant 2. So which angle in the second quadrant has a cosine ratio of negative radical 3 over 2? 5 pi over 6. Man, I like this pi over 6 angles on this slide. And if you need to draw the little visual, okay, they come from the second quadrant. All right. Inverse cosine of -1. Write down what you think the answer should be while I fill up my water. Inverse cosine of -1. write down. Pi, the cosine ratio at pi is -1. All right, how about this one? The inverse sine of 2. Grayson's freaking out over here. Why is Grayson befuddled? Two. I don't care that that's not a unit circle number that we're used to seeing. That is not what makes this weird. Well, we're okay without the parentheses. Yeah. Can you go look at the domain for inverse sine? What's the domain? The domain is -1 to 1. Is 2 in the domain? No. Grayson tried to do it in his calculator. He got a domain error, is exactly what it says. Okay. We cannot have anything above 1 or below -1 in our inverse cosine or inverse sine function. When there is, not going to work. It's going to be undefined. Okay. Do you have an idea?
No, there's
Thinking with your hands. I do that sometimes also. Inverse tangent is a first and fourth quadrant output. Okay, we got to remember which type of angle is going to give us radical 3 for a tangent ratio. Is it pi over 6 or pi over 3? Pi over 3, because we'd have y over x, and those would cancel to be radical 3 over 1. Okay, so pi over 3. So since I'm asking for a negative radical 3 and an inverse tangent, you would rotate to negative pi over 3. I really like inverse tangent and inverse sine because you only have to think about the acute angle. Okay, what is it in the first quadrant? If it's negative, make it negative into the fourth quadrant. Okay, now let's talk about your calculator. I don't know why you're packing up. We have plenty more to talk about. Okay, let's talk about your calculator. Get it out. Okay, first of all, I want you to make sure that you're in radian mode. If you haven't touched your calculator since the quiz, then you're probably not in radian mode. Okay, so your inverse trig functions are the second of your normal trig functions. Can you find them? Wherever sine, cosine, and tangent are, when you press second sine, that's your inverse sine. When you, what? That means you didn't type it in, right? Well, yeah. Okay, so go ahead and punch in the inverse tangent of -8.45. And to 4 decimal places, make sure that you can get -1.453. Okay. I don't know why I'm using my highlighter to do that. Okay, just for the fun of it, so you know what happens in your calculator, go back to that inverse sine of 2 What happens when you try to punch in inverse sine of 2? It should say domain error. Do you get that? Okay. When it says domain error, the number you have can't be an input. All right. You have only a handful of problems on your homework that you're going to be asked to use your calculator for. The rest, I need you to be doing without a calculator. Okay. So we're going to look at some composition problems to end our time together. Okay. We have 12 minutes, plenty of time. Composition, a function inside of a function. So what happens if we compose a trig and an inverse trig function together? I need you to remember our domain and range for your inverse trig functions. Our inverse trig functions are very picky. Okay. Inverse sine and inverse cosine have inputs between -1 and 1. Inverse sine and inverse tangent have outputs, -π/2 to π/2. Inverse cosine have an output of 0 to pi. Okay. So, did you write down this problem? If you haven't, make sure you do. Okay. Cosine of 2π/3. And then the arc cosine of -1 is 2π/3. Because 2π/3 is a first or second quadrant angle, and our outside function is arc cosine, it is possible for these to undo each other. That's what happened. But unfortunately, that is not going to happen every time. Let me show you why. Write this example down, please. Okay, in this example, why is this not possible? We can sine has a domain of all real numbers. That's not what we need to worry about. Okay, we need to worry about our inverse trig. Can arc sine have an answer of 5π/3? No, it can't. So we have to do this one individually. We have to do this step by step. What is the sine of 5π/3? So now if I ask you for the arc sine of -√3/2, well, that can only come from the first or fourth quadrant. Since it's negative, we have to rotate negatively to the fourth quadrant to get negative π/3. Honestly, if it were me, since these inverse trig ones are so picky, I wouldn't even try to do this right here. I would just do it step by step like we did it in this, okay? Don't even try to cancel them out because it's not gonna happen very often, okay? Go and write this one down. Any ideas on this one? What? These two can cancel. Arctangent has a domain of all real numbers. So it's not super picky about its domain, which means tangents range isn't picky. Hey, remember inverses, they switch domains and range. So this one we actually can cancel out. Okay. Now, yes. How would you work through that? Is exactly what I was going to talk about. So arctangent is talking about some angle theta. Since the arctangent is -5 inside, which quadrant would this theta be in? Has to be first or fourth. Okay, so it's the fourth. And our tangent ratio is 5/1. Okay, but in this case, it'd be right 1, down 5. Okay, so here's our theta. So now this is theta. Now we have, what is the tangent of theta? Well, the tangent of theta, opposite over adjacent, is -5/1. Okay, should we do another one of those? I think we should. Two-thirds, that's not a unit circle ratio. When you are given a non-unit circle ratio, you are gonna have to draw a picture. It's gonna have to happen. Okay. So this right here, we are gonna call theta. Its answer is some angle. Since we're talking about arc cosine, theta is gonna be either in the first or the second quadrant. In this case, since it's a positive 2/3, which quadrant are we gonna draw it in? And our cosine ratio adjacent over hypotenuse is 2/3. All right, help me out. What's our opposite side? Radical 5. So now I want the tangent of this theta. Well, the tangent of this theta is opposite over adjacent. How's that sound? One last example. Don't think too hard. Is this -3?
Yeah.
No, it's not. What did I tell you about inverse cosine and inverse sine? This is not in the domain of -1 to 1. Okay, if you would have tried to make a triangle in the fourth quadrant with a cosine ratio of adjacent over hypotenuse, there would have been a problem. Can I have a cosine ratio of 3/1 and our hypotenuse is 1 and our adjacent side is 3? That doesn't even make sense. Okay, that's not geometrically possible. Okay. All right, I need you to do the best you can on your homework tonight. Okay, have your notes out so that you can look at these cute little pictures of which quadrants you need to be grabbing angles from. Okay.